least common multiple. So now this is the start of how you would add fractions that do not have like denominators. So fill in the red again, pause it, because I'm going to move on. So LCM is the way that you're going to see it. Just like we shortened the greatest common factor, we're also lazy and we shorten least common multiple. So when you see it, it's just going to be LCM, and that stands for least common multiple, which is the common multiple with the least value. They kind of use the words in the definition, so it doesn't make much sense yet. But there's two ways you can find it. One is making a list, and the other is with a factor tree, which should sound familiar because the same way that we found greatest common factor, you could either make a list or make a factor tree. It's just the only difference is when you make a factor tree, when you get to the end, you're looking for a different product or a different rule, I guess. So, for example, if we made a list, it's literally just making a list of the numbers. So find the least common multiple of 4 and 10. What this means is the smallest number that they both could be multiplied into or divided into. So for 4, multiples of 4 are 4, 8, 12, and then we've got 16, and then next comes 20. And then for 10, multiples of 10, we've got 10, 20, 30, okay, it could go on, 30, 40, 50, 60. But I can stop here. I'm looking for the smallest number that they both can go into. And so if you look, we already found it, and it's 20. Both of these numbers can go into 20, and that's the smallest number, the smallest option for both of them. So the answer for the LCM is 20. All right. Factor tree away takes a minute, so let me draw it out. We've got 6 and 10. If you don't remember how to make factor trees, it's where you have to keep listing two numbers that can be multiplied into whatever the top of the tree is. So right now the top of the tree is 6, and you can multiply 3 and 2, and those are both prime. So you would circle both of them, but I'm not going to circle them because when I do, it gets real sloppy with this mouse. And then over here for 10, you have 5 times 2. Again, both prime. So you should circle them on your paper. I am just not, because you wouldn't be able to read it anymore. So we're not done, but we've done the math part. Now we have to list it out. So if we had 6, our multiples are 2 and 3, or 2 times 3. That looks like a greater than or less than. There we go. And then for 10, you have 5 and 2. So 2 times 5. Hopefully you remember how to do this. Okay, still not done. Whenever you're doing least common multiple, if you read back up here, it says you find the largest number to times each different factor. So if you look back here at the list we just made, avoid the 6 and the 10. Those don't matter, but you've got 2, a 3, another 2, and a 5. Think back to when we did greatest common factor. Sometimes we had exponents attached to these. Here we do not. So, but if we did, it'd technically be 2 to the power of 1, and 3 to the power of 1, 5 to the power of 1, 2 to the power of 1. Hope that doesn't confuse you. But there's no exponents attached to these. And now we have a 2, a 3, and a 5. Technically, there are 2 sets of 2s, but we don't care because we only need to use one of them. We took one of every number. It says you need to take the different factors, which we just circled all of the different options, a 2, a 3, and a 5, and now multiply them together. So if you were to multiply 2 times 3 times 5, let's see, 2 times 3 is 6, 6 times 5 is 30. So that's how you find your answer using prime factorization, which we will do more practice with because that was probably really confusing. Make sure you have all this copied down and then go to